Well, in true cat fashion, this one right here has decided to get in the way of my problem, so we're going to have to relocate. Oh no. Okay, so relocating kitty. Not very pleased about it. So let's go back to working on these problems. These are going to be the last two Sigma formats that I'm going to do. I am going to do one more video with just fractions in general in terms of patterns, just to make sure we're all good. But this first example, I'm going to call this A, and I'll call this one B. So with example A, if you notice, this time we're starting with the third term and we're going up to the seventh term. So if I write these out, n equals 3, n equals 4, n equals 5, nope. N equals 6 and n equals 7, I'll have the ability to see all 5 of these terms. Now, if you notice, this is not going to be necessarily intuitive because you're starting with your third term and going up to your seventh term. Most people will tell you that means 4 terms, but when you're counting things out physically, you actually have to consider that you've got that one additional piece in there. The difference between 3 and 7, the difference is 4, but the count of items between 3 and 7 is 5. So you got to be really careful with that. So anyway, we're going to have these 5 terms. We're going to have 16 times 3/4 to the third, plus 16 times 3/4 to the fourth, plus 16 times 3/4 to the fifth, plus 16 times 3/4 to the sixth, and thank goodness, because I'm running out of room, 16 times 3/4 to the seventh. Now, you can do this by hand, or you can use a formula. You can definitely 100% use S sub 5, and I'll get to why I wrote 5, with the following pieces. Sum of the first 5 terms. If you say that my first term is 16 times 3/4 to the third power, and your ratio, the thing that's changing in between each term, well, the only thing that's been changing in between each term is that 3/4 multiplication here, because you're doing 3/4 to the third. Okay, now you got another 3/4 because it's to the fourth. Then you got another 3/4 because it's to the fifth. Then you got another 3/4 because it's to the sixth. So you've got a ratio in between each term of change by 3/4. So you can absolutely use this, or you can just, work these out by hand and do it by hand. Either way is fine, but this is a nicer, more concise way of doing this. So S sub 5 would be 16 times 27 over 64, because that's 3/4 to the third power. I have to move the cat one more time. Stay there. All right, where was I? Oh yeah, 16 times 3/4 to the third power, 3 to the third is 27, 4 to the third is 64, times 1 minus 3/4 to the fifth, all over 1 minus 3/4. Again, not pulling this out of thin air. This comes from the summation formula for a geometric series, where it says that the sum of the first n terms is made up by the first term times 1 minus r to the n, all over 1 minus r. So here it's algebra time. I'm going to go ahead and reduce this because 16 and 64 can both be reduced by 4. Let's see, if you divide 16 by 4 and divide 64 by 4, you get 2 over 4, which means that you can reduce it one more time. I don't know why I forgot that you can actually do this, 1 and 4. So we're going to have 27 over 4. And then over here, we're going to have 1 minus 3 to the 5th. All right, 3, 9, 27, 81, 243. 4, 16, 64, 512. Nope, I lost it. We're going to pull out the big guns here. Yes, this is my old beat up calculator. Alright, 4 to the 5th. 1024. All over 1/4. Alright, so this is 1, so 024 over 1024. I'm just making a lazy man's common denominator here. So 27 over 4 times, still too early in the morning, my brain isn't fully on yet, 781 over 1024 times, and then I'm going to do times because when you divide by a fraction, you're really multiplying by a reciprocal. And you know what? I'm just going to do this because I love you too much to let you watch me suffer through this multiplication. And, ugh, see? Thank goodness. That is not fun. Oh, look at that. So basically all that they did was cancel out the 4s and then did 27 times 781. That makes sense. Alright. Just make sure that that is actually what happened. Yep, sure is. Alright. So 21,087 all over 1,024. Now again, because I've got the big guns out, I'm just going to go ahead and check my work up here. So, use my summation. X equals 3, 7 at the top, extra parentheses, well, not yet, we're going to put them in a second, 16, 3/4 to the X, and that looks like it's the same thing. Yep. So, there you go, there's the first example A. My video ran a little bit long, so I'm going to pause here, give you a break, and then I'll pick up with example B in the next video.